What's up, guys? Chapter 5, Ideal Gases, Single Phase, Mass Balancing. So we have this number 42, and we're going to talk about this problem, which is suddenly you purchase a gas cylinder, so it's a cylinder which contains gas. It's supposed to contain 5% mole of chlorine. That may be changed 0.1 plus or minus 0.1. And the balance is air. The experiments you have been running are not giving the reasonable results, and you suspect that the chlorine concentration in the gas cylinder is incorrect, so this probably is wrong. To check this hypothesis, you bubble gas from a suspicious cylinder, so this cylinder, through 2 liters of an aqueous solution. So you have this solution, which is essentially the solution. It's 2 liters, that's the volume, and 12% by mass NaOH, and has a specific gravity of 1.13 for 1 hour, so time equals 1 hour. The inlet gas is measured at a gauge pressure, so they give you this pressure. Let's use pressure gauge equals 510 millimeters of H2O, and the temperature of 23 Celsius. Prior to entering the vessel, the gas passes through a flow meter that indicates that the flow is this. So we have an actual volumetric flow, 2 liters per minute. At the conclusion of the experiment, a sample on the residual is analyzed and results that it reduces by 23. So we are going to absorb 23%. Find the concentration or molar concentration of Cl2 in the cylinder. So we have this equation, and let me continue. So let me draw a better diagram. So they enter this tank, and you get air and 3 and 2, it's air. This is chlorine. This is, and you have volumetric flow, which is 2 liters per minute at 23 Celsius and 510 millimeters of meters of H2. You have N1. Well, you don't have it, but you know it is there. N1 minus y. This is air. This is chlorine. Now, the first thing I want to do is to know what's the amount of solution used. They tell you it's 2 liters solution, So I have volume, but I don't want volume, I want mass. You know, we can relate volume and density because it's a liquid. This is a liquid, the NaOH, it's a liquid. So the density, I don't have it, but I have the specific gravity, which is 1.3. So I'm going to use this 2 liters times 1.3 grams per milliliter, but I need to change it, so I'm going to change 1000 milliliters to 1 liter. So doing this, you should get something around this, grams of solution, or 2.26 kilograms of solution, whatever you want to use. Now, by the concentration, they give us the concentration of 12% by weight of NaOH. We can relate that, we know this is 12 grams per 1 gram of solution. And I don't want that, I want, let's change it to mole, so we can relate for the stoichiometry, for stoichiometry uses. So, 2 grams of NaOH. How much do they? I think they weigh 40. 40 grams NaOH. 1 gram mole of NaOH divided by 1 gram of solution. So essentially, this is going to be how many moles do I have per gram of solution. So doing these calculations, I get 0.003 gram mole of NaOH per gram of solution. I know this is kind of strange, guys, but we're going to fix it, don't worry. And yeah, essentially, let's continue. One thing here, guys, this is kind of tricky. There's a 23% here. Reduce it by 23%. What does that mean? It means that 23% has actually been used in the reaction. I'm going to suppose that. So let me change this thing here. I know how many more? 2,260 grams of solution is what we have. So mass of solution times, if we multiply this times this thing here we just got, we will get the total amount of moles, which is what I want. Mole of NaOH divided by 1 gram of solution. We're going to take out gram solutions and let's see how much gram moles do we have. It should be, where is it? Let me check it. 2.26 times. Yeah, you will get 0.00678 gram moles of NaOH in that solution. But we don't want this because we know it's only the 23%, so let's do it. Let's check it. This is the total amount of moles, but we want the 23%. 23% will be essentially just multiplied by 23. Give you 1.001 gram moles absorbed. Just let me check. This is too small, which, oh yeah, I have one little comment here. I use kilograms here, not grams, so sorry. We should actually make this a comma. If you're in America, you will understand this is 2,260. Sometimes I mix commas and points, so sorry about that. So this will be actually, this is the correct value in grams, because this will be actually kilograms. Okay, or kilomoles. So let's use this value. So that's the problem when you start using commas and points, because normally I was used for commas, but then I started to use the comma system, but it's kind of strange because I'm not used to. But anyways, we got this amount. Now let's use, I told you about the stoichiometry, now let's actually use it. So let me go very fast to the equation. And what I want to see is how many moles will give me that here. Chlorine, where is it? Oh yeah. So I need 1 mole of chlorine for 2 moles of NaOH. But what is this? I have NaOH, so how many moles do I need if I have 1.5 gram moles of NaOH? So this one is easy, it's actually only 1.5 gram moles NaOH divided by 2 gram moles NaOH and 1 gram mole of chlorine. Essentially, you should get 0.70, let me check the number, 75 gram moles of chlorine. So that's the stoichiometric value I need. So that's a flow. We know this, the time the guy used, it was 1 hour. Let's do it in minutes, 60 minutes. So if I wanted mole flow, I will have moles divided by time. I have moles, yes, 75 gram moles of chlorine. Time, yes, I have 60 minutes. So I divide this and I get this flow of chlorine, which is N2. Let's go to N2. What is this? No, it's N3, sorry. We just calculated this, N3. Now, guys, they tell you what is the actual question, because sometimes I forget, is the concentration. Okay, let me find it. At the conclusion, okay. What is the concentration? Okay, this is the question I want. The concentration. So let's do it. This is N2, just to let you know, N2 equals 0.013 mole per minute of chlorine. So if I wanted to do a mass balance in chlorine, I will have inlet minus outlet plus consumption, production minus consumption equals accumulation. We have an accumulation, we have, yes, production in out, but let's see if we could, since it's absorption, I'm going to use essentially inlet equals outlet. So the inlet is essentially, see, the mole fraction in the inlet, which is N1, and N2 times XCl2, which this is essentially 1, only 1. And this is what we want here. So let me just, I think we're almost done. We have N1, no, and N2 we have it. So let us go find N1. N1, which will be essentially using ideal gas and standard conditions. Please, if you don't know what I'm doing, you should be reviewing the classes on ideal gases, especially the standard definition. So we have this, the volumetric flow is 2 liters per minute. TS, I don't know. Actually I know, it's 273. Then 23 plus 273. Pressure, I don't have it, but yeah, I think we need to check it. It's 510 gauge, so pressure is 510 meters H2O gauge. So just to let you know, 1 atmosphere equals 10.33 meters of H2O. So if I have 500 millimeters, is almost nothing. So let's change these to millimeters. 10.3. To 1, I don't know what atmosphere. And you get, let me check the value. 0.05 atmospheres. But that's gauge, so our pressure will be 1 plus our gauge value divided by 1. NS, it's 1 kilomole per 22.4 cubic meters. And after doing this, well, we need to change, because we have liters, let me use 1 gram mole per 22.4 liters. Using this, you get 0.0864 gram mole per minute. So that's our flow. And now we can calculate our concentration, finally, XCl2. And 2, how much do we have? It's 0.0313 gram moles of Cl2 divided by 0.0864 gram moles of CO in inlet outlet. Then I get 0.15, which is essentially 15%, and those guys told me it was 5%, so they're lying to me, and I'm sure because of the mass balance. So let me overview the problem. It was kind of strange, but we got this tank. They assume it's 5% and they sell it to you like that. So what I want to do is this crazy project in which I add this NaOH and something will get absorbed. You need to know, of course, these values, how much volume you used, what is the density of the solution, what else do you need, how much it's absorbed. I think this is very difficult to get, will be the main issue when you send your report to your boss or to your to the provider, the seller. They will tell you where do you get this 23% data, or do you have a machine, equipment, or what? And yeah, after that we get the total amount of moles absorbed with the relationship we know from stoichiometry, we get this, and we know how much moles of chlorines did we absorb. We continue, we need this on time. This is kind of strange because we got the amount of moles but not in time, and we know it was in 1 hour, so we calculated. Then we just keep doing mass balance, in goes out, so this goes in and this goes out. Be aware of this conversion. I looked in the internet, you don't know to know it. It's very strange. Actually, millimeters of H2O is almost nothing. And what else can we see? I use standard conditions and I got the total amount of moles. I just balance from mass balance here. Where is it? Yeah, here's the mass balance. From this here, I got this equation here. And yeah, I just substitute the data and I finish my problem, guys. So that's everything for this video. Keep continuing with the videos on mass balancing, guys.